What do you understand by the word probability?
I think probability, for me, I think uncertainty. Like if you're not certain about something.
Then that is probability. Okay.
Yes.
Yeah, it is also a good idea. So in the probability, we look at the chances of something happening. That is in a simple way. The chances that something may happen. For example, currently we are in a rainy season. So we can look at the probability of it raining or not raining. So that would be, so we are looking at the chances that rain might come or rain might not come. And here they are saying probability, how likely something is to happen. So we measure the chances that something is going to happen. So we are saying many events cannot be predicted with total certainty. So we cannot wake up one day and we say tomorrow it is going to do what? To rain. So we can't say totally it can't rain. So there are chances that it may or it may not. And we are adding to say the best way. The best we can say is how likely that happen using the idea of probability. Have you ever tossed a coin?
Yes.
So what do you do when you are tossing it, and what comes out of the process?
Like, okay, if you're toasting a coin, there are chances that both the tail will appear on top, or the head will appear on top.
And what would be the probability or the chance that the head appears on top?
The probabilities are half that the head will appear, or it's half that the tail will appear.
Okay. Thank you. So that one we have seen here, the tossing of a coin, because we expect two outcomes, which is a head and a tail. Then how about a die? I normally see people playing games with it. Have you ever played that game?
Yes, I've ever.
You have ever. So you are using probability in your life.
Yes.
Okay. So what are the chances that a die will show maybe a face showing 6? Okay, first
The
of all,
chances that
yes, continue.
I think the chances is 1 out of 6.
1 out of 6.
Yes.
Because it has a total of
6
faces. Okay.
Yes. Yes.
Okay. So okay, what are the chances that it will show the faces showing will be prime numbers? Do you know what prime numbers are? So we are saying our die has a sample space of numbers from 1 up to 6. So in here, there are quite a number of questions that may be asked, okay? So we may be asked to get the probability of even numbers or even faces showing. So what are the even numbers from this sample space? Okay, I was asking about the even numbers that are in this set above, a set of sample space.
Excuse me, I didn't get your question.
Okay, let me come again. What are even numbers that are in this set here, that are in the set 1, 2, 3, 4, 5, and 6?
The even numbers, we have 2,
Yes,
we have 4, then 6.
4 and 6.
Yes.
So what would be the probability of getting even numbers?
It will be 3 out of 6.
3 out of 6. And this one we can simplify it to
A half.
to a half. Okay. So in here we are looking at the even numbers. So we call this in probability language, we call this an event, and it refers to the desirable outcomes. So we call that an event. Is that clear? Then we also have a sample space. So what do you understand by the word sample space? What do you understand by the sample space?
Okay, the sample space, I think, is the set of all the possible outcomes after the experiment has been carried out.
That is very good. A set of all possible outcomes. So that gives us a sample space. And then we are saying probability of an event is going to be equal to, when we generalize it, it will be number of E, which represents event, divided by number of S. So the S in this case represents the sample
space.
The sample space. Okay, let us look at another one, still from that. What can you identify prime numbers?
Prime numbers, we shall have 1.
As if
1.
they begin with the 2?
No?
Yes.
I thought they begin with.
What is the definition
1.
of a prime number?
According to me, I think a prime number is a number that is only divisible by 1 and itself.
No, a prime, okay. That is okay as well. So is divisible by 1 and
Yes.
by itself. Okay.
Yes. Yes.
So meaning those would be two in our language. Okay, we call them two factors. The proper definition. It has two factors, which are 1 and itself.
1 and itself.
So does 1 have two factors?
No, it doesn't.
So that means it does not qualify to be a prime what? A prime number.
Factor.
Yes, okay, prime factor or a prime number. So what are prime numbers?
Prime numbers are numbers that have two factors, 1 and itself.
Okay. So now after knowing that
So
definition, 2.
I have 2, 3, and 5.
5. So meaning the probability of a prime number will also be 3/6, which gives
Over
us
6. A half.
Which gives us a half. Okay. So that is to do with that. So let us come to let us talk brief in detail about the sample space. So here in the sample space, we have two methods two methods that we use to generate the sample space. So one of it is the tree diagram, and another one is a table of outcomes. Then there is another method, but that one is major used by those who do the principal mathematics. Okay, so for us, we are going to focus more on these two procedures. So we are going to begin with an example where we are tossing a coin 2 times. Tossing a coin 2 times, and we use a tree diagram to generate a sample space. Okay, so we are going to begin. So we are going to, let's say, begin from there. Okay, I'm going to extend it a bit down, then as well there. Okay, so that would be our first time of throwing a coin. Then we can again add on the second time. So still here we have two possibilities of getting a head or a tail, and then here still getting a head or a tail. So here we are going to have that this one can be a head or a tail on the first throw, and then on the second, if we had the head at first, we can as well get a head or a tail, then still here a head or a tail. So here when we are writing our sample space, we are going to follow this, to follow the arrows. So for example, we can have a head and a head. So that would be the first one, head and head. So what could be the next?
The next would be a tail and a tail.
Tail and tail. Yes, another one.
The other one, we can have a head and a tail.
Okay, head and a tail. And lastly,
tail and a head.
Tail and a head. So here would have generated the sample space. So if we are requested maybe to find the probability and what, that one we can continue with it, but we use this as well to generate a sample space. Then we can as well look at a table when we are using the second one, table of outcomes. So we can still use it for the two when we are throwing a tail, when we are throwing a coin 2 times, so we can as well use it. So we are going to write our head here and a tail, and then as well a head here and a tail. Supposing this is our first coin, okay? So this one can be used when we have 2 coins. Then now, where these ones intersect, for example, we shall have a head and a head. So we shall write it as head, head. Is that clear?
Yes.
Then here we shall have a head and a tail.
A tail.
Then here we shall have tail and head. And then in here we can have tail and tail. Then we can now say our sample space is equal to head, 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 tail, tail, head, and tail, tail.
Tail.
Okay. Is that okay?
Yes. Yes.
Then we can as well look at the same when we are using, when we are given a pair of dice, and then we are requested to roll them. Okay.
Yes.
Okay, so let me only draw the vertical lines. Okay, so we are going to number 8. So here we have 1 is a different color, 2, 3, 4, 5, 6. Then still I'll have 1, 2, 3, 4, 5, and 6. So still here we are going to write them. So we are going to write them in pairs. So when we need pairs, so we shall have a pair of 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Is that okay?
Yes.
Then when we go on to what shall we have?
We shall have 1, 2.
Now we begin with the 2. Because here we are beginning with the 1. So this would be 2, 1.
2, 1.
Okay.
Yes.
2, 2. Then 2, 3. 2, 4. 2, 5. And 2, 6. Then here we shall have 3, 1. 3, 2. 3, 3.
Excuse
3,
me,
4.
Master.
Yes.
Is it wrong if you begin with the 1?
No, you'll mix them. Okay, it's better if you begin with the 1, 2, okay, 1 and 2, then you do it across, okay.
Yes.
But since me, I had started with this line first, I have my 1, 1, 1 first, then that is what I will continue with, okay. But if
Okay.
you wish, you can say this is 2, 1, 3, 1, 4, 1. Then you do like the way you are suggesting. It will
Okay.
still give you the same pairs. So this
Okay.
would be 3, 5, then 3, 6. So 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, and 4, 6. So 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, and 5, 6. Then we have 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. So how many would they be in total? Let me come please, just a moment. Okay, I'm back.
Okay.
So what would be the total number of the sample space?
The total number will be 36.
36. That is great. So after generating this sample space, we may be asked a number of questions on it. For example, to get the pairs that have doubles that are appearing 3, 3, 4, 4, 5, 5, 6, 6, 2, 2, 1, 1. So we can be able to extract the number and then have it over 36 to get our what? Our probability. Then we can also have where we have the even pairs. So they might as well ask for even pairs. So even pairs is where we have like 2, 2. So this one still counts. Then 2, 4.
2, 4, 2, 6.
Yes.
Then here we shall have 4, 2 on the next. Then 4, 4, then 4, 6.
Okay.
Then we go to 6, 2, 6, 4, then 6, 6.
Okay. So I think still after knowing how to generate this sample space, we don't find it hard to compute the what? The probabilities. Okay. So after saying that, we can go ahead to look at some formulas. So we are going to relate them more to sets. So where we shall look at the interaction with the set theory.
Yes, that's where the challenge is.
Let me first draw some 2 circles here. So after drawing this, here we shall have A intersection B complement because we don't have any member of B in this side. Then this area shared by the 2 is A intersection B. And then lastly here we shall have A complement. So the complement means
Complex.
it is not part. Then intersection what? B. Yes, let me again have something closing it. So here we shall have number of universal. Then, so we can begin from here. So in the probability, we have seen that probability of an event is the number of events divided by number of sample space. Okay, so we are going to begin with A. Okay, so if we wanted number of A, what would it be equal to? So we look at what is inside this, the circle of what? Of A. What is inside A? So meaning that would be number of A, complement of A intersection B, complement, then plus number of A intersection
B.
Yes, so we are going to divide by number of sample space since we want to convert them into probability. So still this divided by number of sample space. So when we divide, it now changes to what? Probability, because we are saying number of E over probability of over number of S is equal to probability of what? Of E. So what is number of S of A over number of S? What will it give?
I didn't get your question.
Okay, we are saying here that the number of S, number of E divided by number of S is equal to probability of E. So when we have number of A over number of S, what will it give?
As we have now to get the final answer here down.
Okay, this one is going to be probability of A, okay?
Into, okay, I get the answer now.
So what will this one be equal to?
It will be probability into brackets A intersection B complements plus probability into brackets A intersection B.
Okay.
Yes.
So also look at the set B. So number of B is going to be equal to number of A intersection B plus number of A complement intersection B. Then since we want them in probability, we are going to divide by the total number of sample
space.
Sample space. And this is going to be probability of B is
equals to probability into brackets A complement intersection B.
This other one is there. We are beginning with A intersection B. Then A complement intersection B. So this might become our second
equation 2.
Okay.
Yes.
Yes. Then we can look at the general one where we want probability of A union B. But we want to express it in terms of probability of A plus probability, and probability of B. So majorly A union B would be when we get this circle. Okay, this plus this plus this. But we want it to be more general so that we express it in terms of A and what? And B.
B.
Yes, so we are going to say this is equal to probability of A plus probability of
B
but
plus probability.
When we do that, don't we see that this one is appearing 2 times when we add probability of A and probability of B?
Yeah, it appears 2 times.
And yet we want it to appear only
once.
So what do we do?
So we shall take it away.
Okay, thank you. So we shall take away A intersection B.
B.
So the formula for A union B probability is probability of A
plus probability of B
minus probability of A intersection B.
B.
Is that one clear?
Yes.
Yes, so we now continue and add. So if we have A, okay,
Yes.
there are chances that okay, if it rains, if we are still predicting, there are chances that it can rain and there are chances that it cannot do what?
It cannot rain.
Yes. So therefore we can as well say probability of A prime plus probability of A is equal to 1. Okay. If A represents raining,
Yes.
this one will represent not what? Not rain.
Raining.
Okay. Then still probability of B plus probability of B prime. This one will give us still a what? A 1. Is that okay?
Yes.
Okay. Then we can have a general, we normally call it a contingency table, so that we can use to summarize this information. Let me briefly draw it here. So this table enables you to easily remember these probability formulas. So we are going to call this one A and this one A what? Prime. Are we there?
Yes.
And that should be equal to a 1 there. Then here we shall have B and B prime.
Prime.
Then here a 1 as well. So we are going to say B and A, that would be A intersection.
A intersection B.
Then here
will be A complement intersection B.
Okay. Then here
shall have A intersection B complement.
Then here
that one we shall have A complement intersection B complement.
Okay. So now this table enables us to generate all these formulas here. So we are going to, so if we want probability of A, we move downwards, okay? Probability
Yes.
of B of A prime, we still move downwards. Then probability of this and this is equal to 1, okay? Probability of B and B prime is equal to 1 still. Then probability of B, we move like that. Probability of B prime, we still move like that. So can we state these formulas very fast?
Yes.
Mm-hmm.
So for probability of A, we shall have probability in two brackets, A intersection B, close brackets, plus probability of A intersection B complement.
That is 1.
Then for probability of A complement, we shall have probability into bracket A complement intersection B plus probability into brackets A complement intersection B complement. Then for B, probability of B, we shall have probability A intersection B plus probability into brackets A complement intersection B. Then probability of B complement shall have probability into brackets A intersection B complement plus P probability, which is into brackets A complement intersection B complement. Then for probability of into bracket A plus probability into brackets A complement, we shall have a 1. Then for B, probability into B plus probability into brackets B complement, we shall also have 1.
Okay. So there are others that we haven't proved, but they are as well indicated. They are proved by shading, okay? But I can as well list them here. So probability of A union B complement is the same as probability of A complement intersection B complement. So that one, when we get to the Venn diagrams and we shade them, this area here is the same as this area. Okay, so when you shade A complement and you again shade B complement, that area, the intersection of that area is the same as probability of A union B complement. Then we also have probability of that is it. Let me see. So when you reverse it, it is the same thing that we shall use. So those are the formulas that we have. So I think we can briefly look at an example of how they can be used Okay, and then we call it a day. So we are saying events. Let me do some typing here. I'll be a bit faster. Events A and B divided by 30. Probability of B is equal to 2/5. Probability of A union B is equal to 4/5. So we find probability of A intersection B so we can begin with that. I hope it is visible. So we have that probability of A is 19/30, probability of B is 2/5, and probability of A union B is 4/5. So we are requested to find probability of A intersection B. So which formula are we going to use?
We are going to use this formula of probability of A intersection B.
Sure. We are going to use A union B. Okay.
Yes.
So this we said is equal to
probability of A plus probability of B, take away probability of A intersection B.
Okay. So we are given A union B as 4/5.
Which is 4/5.
Yes.
Then probability of A is 19/30.
Yes.
Plus 2/5. Then they tell us to take away probability of A intersection B.
Yes. Do you have a calculator?
Yes.
First add 19/30 plus 2/5.
We shall have 19/30 plus 2/5. We shall have 31/30.
31/30. Okay.
Yes.
Okay. So 31/30 equal to 4/5 minus probability
take
of
away
A.
B probability. Yes.
So what are we going to do here?
We are going to shift this 31/30 to this other side of 4/5.
Okay. And it becomes a negative.
Yes.
So what is 4/5 minus 31/30?
There we have -7/30.
So what will be our next step?
I think our next step will be, since we are looking for this other one,
Yeah.
decide we shall divide both sides by -1.
Okay.
Then I think
So when we divide here, this will become positive. This one as well will become what? Positive.
A
So,
positive. Yeah. 7 out of 30.
okay.
Yes.
So I guess for now we can stop here. Okay.
Yes.
I'm going to get some little time and record some more videos, or we can meet again and
Yes.
we discuss them. Okay.
Okay. Yes. Thank you.
Welcome.